Section 4.6 has to do with rational equations and partial fractions. The first thing we're going to do here is we're going to work on solving some rational equations. The dynamics that you have used to solve for an A are still in place, but these equations are a little bit more complicated. My suggestion to you on these would be that you find a common denominator across the board. And so that, looking at the common denominator, you can see that if I factored that second term, it factors into a plus 1 and a minus 1. So if you were looking to see what both sides and all three terms had in common, what you would see was that they have an a plus 1 and an a minus 1 and an a. So the common denominator is literally, well, actually this isn't an a, that's over 1. So the common denominator is going to be the a plus 1 and the a minus 1. This a right here is missing both of those, so I'd have to multiply the top and the bottom by a plus 1 and a minus 1. So I'm going to do the, and of course I could do it like this, a squared minus 1, because that's what that's equal to. And then this one's not missing anything, so that would be an a squared minus 5. And then over here, I would have to multiply the top times a minus 1, because that's what the bottom is missing. So basically you're multiplying the top and the bottom by that so that you get that as a common denominator on the bottom. So over here I've got a cubed minus a plus a squared minus 5. Over here I'd have to distribute both of those, so I have an a cubed plus a squared plus 2a. Then I'm going to go back and do the negative 1. Minus a squared minus a minus 2. Now each one of these are over a squared minus 1. That one's over a squared minus 1, because that's what that's equal to. So if I multiply both sides by a squared minus 1, it gets rid of the bottom, which is why I did a common denominator all the way across. So on one side I have a cubed plus a squared minus a minus 5. On the other side I have a cubed, and I don't have any a squared, so I have 2a minus a, which is a positive a minus 2. So now I'm going to seek to solve for the a. I'm going to add an a cubed to both sides, or a negative a cubed if you will. So that goes away, that goes away. I have an a squared minus a minus 5 on one side and an a minus 2 on the other side. Well, if I bring it all to one side, I can either factor it, I can use the quadratic formula. So let's do that. I've got a squared minus 2a plus 3. No, minus 3. Or we'll just do plus a negative 3. And that's going to equal 0. So I can factor that into a minus 3 and a plus 1 equals 0. If you did FOIL on that, I believe that's what you would get. So when I solve it, I get a equals 3, and I get a equals negative 1. But you need to go back and put it into the problem, because you can see if I put negative 1 in here, I would get an undefined, because I would get 0 on the bottom. So I'm going to mark that out, and I'm going to go a is equal to 3. All right, let's do another one of those. First thing I need to do is I need to factor this on the bottom that I can break apart. So these right now are going to stay the same that they are. And this one's going to break apart into x plus 4 and x minus 1, because when I unfoil that, that's what I get. So if you look across here and you're trying to find a common denominator between here, here, and here, the common denominator is going to be this, x plus 4 and x minus 1. So this term right here is missing the x minus 1. This term right here is missing the x plus 4. Okay, so if I continue to proceed with that, what's on the bottom here is an x plus 4 times an x plus 1, or x minus 1. This side, I'm going to have the same thing. The top's not going to change because I'm not changing that fraction at all because it has the common denominator. But over here, I'm going to distribute my x, so I have an x squared minus x, and if you will, I'm going to add the opposite here. So I have a negative 2x minus 8. So if I multiply both sides, let me fix this real quick. If I multiply both sides by the denominator, so I'm multiplying by x plus 4 and x minus 1. Then those are going to go away, and I'm only left with what's on the top. That's why I found a common denominator across the board. So then I have x squared minus 3x minus 8 equals 20. I want to bring it all to one side, so I can either factor it, I could complete the square, I could use the quadratic formula on it. So that's going to give me a negative 3x, and when I bring it over, I have a negative 28 equals 0. Again, if you wanted to use the quadratic formula, you could. I'm going to factor. So I have an x, and I would have a negative 7 and a positive 4. And that's what would give me the center term and the last term. So when I solve this, I get x is equal to 7 and x is equal to negative 4. Again, if you put it back in, notice that if you let the x be equal to negative 4, I would have a 0 on the bottom, which I can't have, so I'm going to mark that one out, and I'm going to circle that one. Now, sometimes they both work. There are times that neither one of them works, so make sure you go back and check it. All right, another part of this section is you're going to decompose a expression, a rational expression, into its partial fractions. And what I mean by that is, you know that this fraction right here can equal, this fraction plus this fraction. Okay, if I just do a smiley face, and okay, this is just meant for you to realize that those are two different fractions. So the first thing I have to do here is I have to factor the bottom. So I have an 8y plus 7 on the top. On the bottom, I can factor this into a y plus 2 and a y minus 2. Now, if I'm going to separate this into its partial fractions, what I'm going to do is I'm going to put one of these on the bottom here, and I'm going to put the other one on the bottom here. Now, I do not know what the a and the b, the part of the fraction above it, is going to be, but that's what we're going to seek to find out. And we're going to continue this the same way that we just did those problems. So I'm looking for a common denominator on both sides. The common denominator is going to be y plus 1 times y minus 1. So this I would need to multiply by y minus 1, okay? And this one would be y plus 2, because that's what's going to give the denominator on the bottom of y plus 2 times y minus 1. Hopefully you see that. You multiply the top and the bottom by y minus 1, top and bottom by y plus 2. So on the top I have a times y minus 1 plus b times y plus 2. On this side I have this. And what I'm going to do is I'm going to multiply to get rid of the fraction. So I'm going to multiply by y plus 1 and y minus, or y plus 2 and y minus 1. So those go away. So I'm left with 8y plus 7 is equal to a times y minus 1 plus b times y plus 2. All right, so I'm going to do two things. First, I'm going to get rid of the a so I can solve for b, and then I'll get rid of the b so I can solve for a. So on this one, I'm going to let the y be equal to 1, because if I do that, then I'm going to totally get rid of the a, because it's going to be 0 times a. So this is going to be 8 times 1 plus 7 is equal to a times 1 minus 1 plus b times 1 plus 2. So on this side I have a 15, and on this side I'm going to have a 3b. So that means b is going to equal 5. Okay, so that's one solution that I need, and then we'll go back and we'll plug these in so you can see what the final answer is. Okay, over here I'm going to let, I'm going right back to here. I'm going to let y equal negative 2, because when I plug negative 2 in there, it's going to get rid of that b. So I've got 8 times negative 2 plus 7 is equal to a times negative 2 minus 1 plus b times negative 2 plus 2. Okay, so that's going to give me a negative 16. Whoops, negative, I'll go ahead and add those together. So negative 16 plus 7, I'm going to get a negative 9 out of that. Then I have a negative 3a plus, and that's going to be a 0b. So that, you can put it there, but it's going to go away. So I have a negative 9 equals negative 3a, or a equals 3. So you're going to use these two to come back here and show what the partial fractions is. So the answer to this is 3, I substituted the a back in here, 3 over y plus 2 plus, and I'm going to put the b back in, 5 over y minus 1. So if I were to take this and break it up into two fractions, these two fractions are the fractions that when I add them together, it's going to give me that. So these are what we call partial fractions, or taking this rational expression and breaking it up into two fractions that when you add together is going to give you the original. All right, let's do another one. Okay, again, the very first step you're going to make is you're going to make this bottom into two parentheses by doing the unfoiling, or what we call factoring. So this is going to be a negative 5 and a positive 2. Hopefully you can see that if I did FOIL on this, it would give me this. So what I want to do is I want to take an a over one of the parentheses plus a b over the other parenthesis. Then I'm going to do a common denominator. So I need to multiply this one by x plus 2. Essentially you're doing it at the top and the bottom so you can have a common denominator, and this one would be x minus 5 and x minus 5. So I have 6x minus 2 over x minus 5 times x plus 2, and then I have a times x plus 2 plus b times x minus 5, and I have x minus 5 and x plus 2. So I'm going to multiply through both sides by your x minus 5 and your x plus 2. And it's going to get rid of the bottom. So then I have 6x minus 2 equals a times x plus 2 plus b times x minus 5. So the first thing I'm going to do over here is I'm going to let a equal negative 2, because that's what's going to get rid of that. So I go 6 times negative 2 minus 2 is equal to a times negative 2 plus 2 plus b times negative 2 minus 5. Okay, so I have negative 12 minus 2, I have a negative 14. This one's equal to 0, and this is negative 7b. So when I solve for b, I get a 2. Okay, so that's one thing I'm looking for. Then I'm going to do the same thing, but I'm going to get rid of your b, so I'm going to let b equal 5. So now I'm going to plug it back in here. So I have 6 times 5 minus 2. I'm plugging it back in everywhere I have an x. And I have a times 5 plus 2. And I have a b times 5 minus 5. Okay, now that's going to be 0. So I've got, right here, I've got a 30 minus 2, which is a 28, is equal to 7a. So a equals 4. Then I come back, and what I'm trying to do is I'm trying to figure out what the a and the b are. So my answer here would be 4 over x minus 5 plus 2 over x plus 2. Those are the two fractions that when I add them together, I would get this original fraction. All right, we're also going to apply these things to solving rational inequalities. So the very first thing you want to do is you want to look and you go, what x value would make this equation equal 0? And that will give you a 0 on the top, and that would be a 2 and a 1. And what numbers for the x would make this undefined at the bottom? So that would be a 3, and that would be a 4. And then what I'm going to do is I've got this number line, and I'm going to put all these numbers on my number line. 1, 2, 3, 4. And I'm going to test each one of these sections to see which one of these is true. So if I have less than 1, and I tell you the easiest way to do this one is positives and negatives. So I'm going to go ahead and rewrite it here. I'm going to leave a little bit of space so that you can see what I'm doing. Okay, so let's say that I have to the left of 1, that would, let's say 0. If I have a 0 here, I would have a negative. 0 here, I would have a negative. 0 here, I would have a negative. And 0 here, I would have a negative. A negative times a negative is a positive. A negative times a negative is a positive. So I have a positive divided by a positive, which is a positive. So that doesn't work. Then I come in here and I do the next section. And I go, okay, I have a 1.5. If I have a 1.5, this is negative, this is positive, this is negative, and this would be negative. So I would have a negative on the top, a positive on the bottom. Negative divided by a positive is a negative, and that would be less than 0. So that section works. I'm going to do the same thing for the next section. So let's say I have 2.5. If I put 2.5 there, that's going to be a positive, that's going to be a positive, this is going to be a negative, and this is going to be a negative. So I would have a positive divided by a positive, which is not going to be less than 0. And then I have a 3.5. So if I have a 3.5, this one's going to be positive, this one's going to be positive, this one's going to be positive, and this one's going to be a negative. So I would have a positive divided by a negative, which is a negative, which would be less than 0. And then if I had like 4.5, every one of these are going to be positive, and that's not going to work. So x is going to be greater than 1, or greater than 1, less than 2, and greater than 3, and less than 4. So that would be your answer right here. You're trying to find the sections with which they work. Here's another one. I think I might have to skip that because we don't have enough time on the video. But let me go ahead and do this one for you. Okay, this one I'm going to look to see what would make this undefined. So there's nothing that would make that 0. Maybe the first move that I would make, so I know 0 is a crucial spot, but then I want to turn around and solve this. So what I'm going to do is I'm going to bring everything to one side of the inequality. Okay, so I am going to make a common denominator here. The common denominator would be 12a. So this one is missing a 4, this one is missing a 2, and this one is missing a 3a in order to make the bottom 12a. So that's going to give me, on the top, it's going to give me an 8 plus a 10 minus a 9a is greater than 0. I'm going to multiply both sides by the 12a, which means I'm still going to get a 0 there. So I'm going to have an 18 minus 9a is greater than 0. I'm going to subtract the 18. And then I'm going to divide by the negative 9, which is going to switch the direction of the inequality. So my other crucial spot is 2. So I want to test between 0 and 2, and then on both sides. So if I came back here and let's say I plugged in a negative 1. If you want to, you could do it all. You could either plug back in here or plug back in here. So this is going to give me a negative 2/3 plus a negative 5/6, which is still going to be a negative number, which is not going to be greater than a positive number. So that one I know is not going to work. Now you can plug in concrete numbers and test it. So let's say I plug in a 1 right here. That's going to give me a 2/3 plus a 5/6 is greater than 3/4. You can do this on your calculator or you could do it by hand. This is going to be a 9/6 is going to be greater than 3/4, and you know that's true because this is greater than 1. So that one works. And then if I do, let's say I plug in a 3. So I have 2/9 plus a 5/18 is greater than a 3/4. So this is going to be a 9/18 when I come up with a common denominator there is greater than 3/4. If I reduce that down, that's going to be, I want the common denominator so I can compare it. So 2/4 is greater than 3/4, and you know that that is not true. The larger one would be 3/4 here, and so that doesn't work. So my value is greater than 0 and less than 2. All right, your homework, well, yeah, I got to finish up this time frame here. Your homework is on page 247 through 248, 12 through 32 even, and not 22.